In this video, we're going to be looking at factoring a sum or a difference of two cubes. So the first step to factoring is always looking for a greatest common factor. So I've emphasized that in every video, and I'm going to continue to do so going forward. The second step is dictated on the number of terms. So we're going to be looking at situations that have two terms, but they are going to either be the sum of two cubes or the difference of two cubes. So the first example, I should say the first case, okay, a sum of two cubes, those will be able to be factored as a plus b times a squared minus ab plus b squared. So notice the binomial to start with is the base of the first term plus the base of the second term. It is the same sign as the binomial that you're factoring. The trinomial that follows, the first term is the base squared minus the opposite sign of the binomial that you're factoring. And then a and b are just the two bases being multiplied. The last term is addition, and it's the base squared. The other example, a difference of two cubes, we could factor that as a minus b times a squared plus ab plus b squared. In both cases, notice the sign in the binomial is the same as the sign in what you're factoring. Okay, these are like, these are the same. The second sign that you're going to write when you're factoring is different in both cases. You might want to mix up my colors here. Okay. These are different. And the last sign is always addition. I'm going to write plus for short. Okay, so a nice shortcut to remembering the signs, because the signs are what trip people up. It's same, different, plus. Same, different, plus. So let's try to factor a couple of these. So the first example, part A, we have x cubed minus 27. So 27 can be written as 3 cubed, which means that we have a difference, subtraction, of 2 cubes. So we're going to factor that, knowing that x is our a term and 3 is our b term. Okay, it's our base. So we have x minus 3, so that's the same sign. X squared, we have a different sign. Now we just multiply our two bases together. So it's x times 3. I'm going to write that as 3x plus 3 squared. So let me just rewrite that because I don't like writing it as 3 squared. I don't like giving my final answer as 3 squared. I'm going to write that as 9. So let's check our signs. We have the same sign. We have a different sign. And then our last sign is a plus. Same, different, plus. So this is going to be our answer factored. And we could distribute that out and combine like terms, and you will find that we get x cubed minus 27. So one more example. B, we have y cubed plus 8. So our y is already being cubed. 8 we could rewrite as 2 cubed. So now this is a sum It's our addition. A sum of 2 cubes. And we could follow the notes that I've laid out above. So we have our 2 bases with the same sign. We add them together. We square the first base. We subtract. That's our different sign. We multiply our 2 bases together. That's 2 times y. Our last term is plus, which is 2 squared, which I'm going to write as 4. That's 2 squared. And that's going to be our answer in factored form. And I'm going to give you some examples that are not a sum or difference of 2 cubes. And, we could play off of part B. If you had something like y cubed plus 9, right? 9, we can't write as something cubed. We could write it as something squared. But something cubed plus something squared, we're not able to factor that. So this does not help us at all. This is not a sum of 2 cubes. And the same thing could be true if we went in the other direction. Say this was x squared minus 8. We could rewrite we could rewrite 8 as 2 cubed. But again, this is a difference of a perfect square and a perfect cube, which we are not able to factor.